atomic and ionic radii. In case of lanthanides, we observe a steady decrease even though there is a large effective nuclear charge. Only small decrease is observed due to the imperfect shielding of 1,4f electron. In case of lanthanides ಅಲ್ಲಿ ನಾವು ಅಷ್ಟೊಂದು ಲಾರ್ಜ್ ವೇರಿಯೇಷನಲ್ಲಿ ಏನಂತ ಡಿಕ್ರೀಸ್ ಏನೂ ಆಗಲ್ಲ, ಲೈಟ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಲೈಟ್ ಡಿಕ್ರೀಸ್ ಯಾಕಾಗುತ್ತೆ ಅಂತಂದರೆ ಇಂಪರ್ಫೆಕ್ಟ್ ಶೀಲ್ಡಿಂಗ್ ಆಫ್ 1,4f ಎಲೆಕ್ಟ್ರಾನ್. ಇಂಪರ್ಫೆಕ್ಟ್ ಅಂತ ಅಂದರೆ ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಫ್ ಆರ್ಬಿಟಲ್ ಏನಿರುತ್ತೆ ಅಲ್ಲಿ ಸರಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಫಿಲ್ ಅಪ್ ಆಗಿರೋದಿಲ್ಲ. ಸೊ ಇನ್ ದಟ್ ಟೈಮ್ ದೇರ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ lanthanide contraction. Okay, so that what is lanthanide contraction? In lanthanide contraction, a steady decrease in the atomic and ionic radii with the increase in atomic number due to effective mutual shielding of 4f electron. Keep in mind, in lanthanide contraction we observe steady decrease in atomic and ionic radii whenever we are increasing the atomic number, because ineffective mutual shielding of 4f electron, that we call lanthanide contraction. And then what are the consequences of lanthanide contraction? Usually there are 4 consequences of lanthanide contraction. Let us see one by one. First one is normal size increase from 4D to 5D series almost cancel out. Therefore 5D and 4D elements resembles each other. In case of periodic table, I mean 4D to 5D series ಯಾಕೆ ಕ್ಯಾನ್ಸಲ್ ಔಟ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಆಲ್ಮೋಸ್ಟ್ ಸೈಜ್, ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಿರುತ್ತೆ ರಿಮೈನ್ಸ್ ಕ್ಲೋಸೆಸ್ಟ್ ಆಗಿರುತ್ತೆ. ಯಾವಾಗ ಕ್ಲೋಸೆಸ್ಟ್ ಆಗಿರುತ್ತೆ ಅಟಾಮಿಕ್ ಆ್ಯಂಡ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಿರುತ್ತೆ ಅದು ಇನ್ ಬಿಟ್ವೀನ್ 4D to 5D ಸೀರೀಸ್, ಸೊ ದಟ್ ಅದು ಕ್ಯಾನ್ಸಲ್ ಔಟ್ ಆಗುತ್ತೆ. ಸೊ ಎರಡು ಕ್ಯಾನ್ಸಲ್ ಔಟ್ ಆದಾಗ 4D and 5D ಸೀರೀಸ್ ಆರ್ ಗೆಟ್ ರಿಸೆಂಬಲ್ಸ್ ಈಚ್ ಅದರ್. ದಟ್ ಈಸ್ ಫಸ್ಟ್ ಒನ್. And second one is it makes lanthanides to possess similarities properties which makes their separation difficulties. So I already told in case of 4D to 5D series distance is very size is very small, so that's why separation is very difficult, and also similarity property ಇರೋದ್ರಿಂದ ಅದನ್ನು ಸೆಪರೇಷನ್ ಮಾಡೋದಕ್ಕೂ ಕಷ್ಟ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್. ಆ್ಯಂಡ್ ದ ಥರ್ಡ್ ಒನ್ ಈಸ್ electronegativity of trivalent lanthanides slightly increases with increase in atomic number. Usually electronegativity of trivalent atom, especially trivalent lanthanides slightly increases with increase in atomic number. Electronegativity usually increases in case of trivalent atom whenever we are increasing the atomic number. That is third one. And fourth one is basic strength decrease along the period due to increase in covalent nature of the elements. That is fourth point. These are the consequences of lanthanide contractions. Okay, and next have to move spectral properties. Usually lanthanides elements they form a color compounds due to FF and 4F and 4D transition. Usually the color that depends on the number of unpaired electron. Similarly in case of D block elements, 4f0, 4f7, 4f40 are the off-filled and completely filled orbitals are most stable. These elements are these orbitals are colorless because off-filled and completely filled orbitals are most stable as due to the absence of unpaired electrons. Okay, this is the spectral property of lanthanides. And next we have to move one separation is there, so that what is that separation? Separation of lanthanides by ion exchange method. This is very important question in the exam point of view, and also lanthanide contraction, lanthanide consequence also very important. Let us see the separation of lanthanides by ion exchange method. Let us see the principle of this one. The ionic radius decreases from lanthanum to lutetium as a result of lanthanide contraction, but in case of aqueous solution, the lanthanides ions are hydrated. The extent of hydration increases with a decrease in atomic size. The radius of the hydrated ion increases from lanthanum to lutetium. When a mixture of lanthanides ions are treated with the ion exchange resin, there is a reversible exchange of ions present in a solid phase and in a solution phase. So that larger the hydrated ions, less bonded, and smaller hydrated ions are strongly bonded to the resin. Thus, the lighter lanthanides are absorbed at the top and heavier ones at the bottom. So that means usually ionic radius decreases from lanthanum to lutetium. So at that time there takes place lanthanide contraction. But in aqueous solution, the lanthanide ions are hydrated. Keep in mind, whenever the extent of hydration increases, there is a decrease in atomic size. And also, larger hydrated ions are less bonded and smaller hydrated ions are strongly bonded to the resin. And next we have to discuss what is the procedure to separate the lanthanides by ion exchange method. Let us see the procedure of this one. Usually in this method, have to take a solution that containing lanthanide ions is passed to the long column of synthetic ion exchange resin. It is an organic compound which is polystyrene that attached to sulfonic acid containing replaceable hydrogen ions. Now the lanthanum ions are replaced by H plus ions. Keep in mind, ಇಲ್ಲಿ ನಾವು ತೊಗೊಳ್ಳೋದು ಯಾವುದೋ ಒಂದು ಸೊಲ್ಯೂಷನ್ ತೊಗೊಳ್ತೀವಿ, ಆ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಲ್ಯಾಂಥನೈಡ್ ಅಯಾನ್ಸ್ ಇರುತ್ತೆ. ಆ ಲ್ಯಾಂಥನೈಡ್ ಅಯಾನ್ ಸೊಲ್ಯೂಷನ್ಸನ್ನು ನಾವು ಒಂದು ಸಿಂಥೆಟಿಕ್ ಅಯಾನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಅಂತ ಇರುತ್ತೆ, ಒಂದು ರೆಸಿನ್ ಅಂತ ಇರುತ್ತೆ. ರೆಸಿನ್ ಈಸ್ ಎ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್, ಅದು ದಟ್ ಈಸ್ ಅದಕ್ಕೆ ಪಾಲಿಸ್ಟಿರಿನ್ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ ವಿತ್ ಆಲ್ಸೋ ಸಲ್ಫೋನಿಕ್ ಗ್ರೂಪ್ ಇರುತ್ತೆ. ಅಲ್ಲಿ ಸಲ್ಫೋನಿಕ್ ಗ್ರೂಪ್ ಇದೆ ಅಂತ ಅಂದರೆ ಯೂಶಲಿ ಹೈಡ್ರೋಜನ್ ಆ್ಯಟಮ್ ಇರುತ್ತೆ. ಹೈಡ್ರೋಜನ್ ಆ್ಯಟಮನ್ನು ರೀಪ್ಲೇಸ್ ಮಾಡಿ ಲ್ಯಾಂಥನಮ್ ಅಯಾನ್ಸನ್ನು ನಾವು ಅಟ್ಯಾಚ್ ಮಾಡ್ಬೋದು. ಲೆಟ್ ಅಸ್ ಸಿ ದಿಸ್ ಒನ್. ದಿಸ್ ಈಸ್ ಲ್ಯಾಂಥನೈಡ್ಸ್. ದಿಸ್ ಒನ್ ಈಸ್ resin, that is polystyrene attached, polystyrene with also sulfonic group. So one replaceable hydrogen atom is there. This is the equation. Let us see this replaceable hydrogen atom. In that the column now contains lanthanum ions fixed on their resin. A lanthanum ions enide resin ge fix agide. Okay, in order of their affinity, this is then eluted with citric acid and ammonium citrate. Thus eluted, that means just treated with citric acid and ammonium citrate. This lanthanum that is attached to synthetic resin treated with ammonium citrate, that is ammonium, ammonium. Now we will get here also takes place, takes place by replaceable lanthanum ion by ammonium. And also ammonium citrate, this is ammonium and this one is citrate. This is citrate reacts with the lanthanum, you will get the lanthanum citrate complex. Those lanthanides with large size loosely held, keep in mind, those lanthanides with large size are loosely bonded and are eluted fast and hence comes out first. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಈ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಅಯಾನ್ಸಲ್ಲಿ ಯಾವುದು ಲಾರ್ಜ್ ಸೈಜ್ ಇರುತ್ತೆ ಅದು ಲೂಸ್ಲಿ ಬೌಂಡೆಡ್ ಆಗಿರುತ್ತೆ ಆ್ಯಂಡ್ ಎಲ್ಯೂಟೆಡ್ ಫಾಸ್ಟು. ಎಲ್ಯೂಟೆಡ್ ಫಾಸ್ಟನ್ನು ಬೇಗ ಅದು ರಿಯಾಕ್ಷನ್ ಆಗಿ ಆ ಕಾಲಮಿಂದ ಫಸ್ಟ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಬಟ್ ಇನ್ ಕೇಸ್ lanthanides are smaller in size, comes out last due to strong attraction. So that strong attraction ಇರೋದ್ರಿಂದ ಸೊ ಅದು ಬೇಗ ಬರೋದಕ್ಕಾಗಲ್ಲ, ಸ್ವಲ್ಪ ಲಾಸ್ಟಲ್ಲಿ ಎಲ್ಯೂಟ್ ಆಗುತ್ತೆ. so that the lanthanide ions are eluted in the reverse order, that is lutetium ions comes first, lanthanum ions are at the end. Lanthanide ions ಯಾಕೆ ಫಸ್ಟ್ lanthanides and lutetium, ಈ ಲ್ಯಾಂಥನಮ್ ಆ್ಯಂಡ್ ಲುಟೇಷಿಯಮ್ ಈಗ 2 ಕಾಂಪೌಂಡ್ಸ್ ತೊಗೊಂಡಾಗ ಫಸ್ಟ್ ನಮಗೆ ಲುಟೇಷಿಯಮ್ ಫಸ್ಟ್ ಎಲ್ಯೂಟ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ದೆನ್ ಲೇಟರ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಏನಿರುತ್ತೆ ಅದು ಎಲ್ಯೂಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಲ್ಯಾಂಥನಮ್ ಲುಟೇಷಿಯಮ್ ಫಸ್ಟ್ ಯಾಕೆ ಎಲ್ಯೂಟ್ ಆಗುತ್ತೆ ಅಂದರೆ, ಸೊ ಅದು ಲಾರ್ಜ್ ಸೈಜ್ ಇರುತ್ತೆ, ಲೂಸ್ಲಿ ಬೌಂಡೆಡ್ ಆಗುತ್ತೆ, ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಎಲ್ಯೂಟ್ ಫಸ್ಟ್. whereas in case of lanthanide strong attraction irodrinda that elute at the end. Okay, this is the separation of lanthanides by ion exchange method.